All right, it's time for a new chapter. We are in geometry, right? That's what we're doing today. Yes, totally is. We're doing geometry, chapter 4, lesson 1. This particular lesson, honestly, this chapter is a lot easier compared to the last chapter in a lot of ways. We are still doing proofs, but the proofs that are in this chapter are some of the easiest you're going to do this entire class. This first lesson especially is really quite simple because really it's pretty much a vocabulary heavy lesson, and it's a lot of vocabulary that we've already seen before probably. So let's dive in. So there are kind of two broad categories, broad ways that we can define triangles. One of them is by their angles, and then you might guess that the other way is by their sides. So let's start with by their angles. So you've heard these words before and you probably know what all of them mean, but just to include it here. So acute. So an acute triangle has we've already talked about acute angles, right? So acute triangle has 3 acute angles. So all 3 triangles are acute, right? So they are less than 90 degrees, right? Obtuse triangles, jumping over here, has 1 obtuse angle. Obtuse angle. What are obtuse angles again? They're angles that are greater. Good grief, excuse me. They're greater than 90 degrees, right? And so it's got this one large angle. The other 2 would obviously be acute, right? Because there's a total of 180 degrees in a triangle. So if you have one that's bigger than 90, the other 2 have got to be smaller, right? So it's got 1 obtuse angle. Oh, I forgot to write angle. How about angle? And then we'll come over here and angle. There we go. Right triangle. That one's easy. So it has what? It has 1 right angle, right? 1 right angle. What is a right angle? It's an angle that is specifically 90 degrees. It's marked with this square mark there. Then the last one. Now this one you may not have heard of. You've almost certainly heard of equilateral triangle. We'll talk about that on the next slide, I guess we'll call it. But equilateral is about the sides. So equiangular triangles has all 3 angles the same. So it has 3 congruent angles. 3 congruent angles. Now, so what are those? What's the degree measure of those? Well, all the interior angles of a triangle add up to 180. So if we take 180 divided by 3, we get 60 for all of these. So they're all 60 degrees if it's an equiangular triangle. All right, so every equiangular triangle is also equilateral, which is the other way that we can define triangles, and that is by their sides. Oh, I guess I forgot to draw the triangles on here, so we're going to get to do it together. I kind of swore I'd done it. Or maybe I didn't save it or something. I don't know. Well, that's fine. We'll do it together. Sounds good to me. So equilateral, I've already hinted all around what an equilateral triangle is. An equilateral triangle is a triangle with 3 congruent sides. 3 congruent sides. Equilateral, 3 congruent sides. Now, you might have kind of put 2 together. You might, in fact, have already known it, that if a triangle is equilateral, it's also equiangular and vice versa. The converse is true as well. Well, it isn't really the converse, but that conditional is also true. Now, an isosceles, you probably know that one. That one's one that we've seen probably for a long time. Oops. Drawing something strange here. I don't know. That's close enough. And it's definitely close enough if we mark this. So an isosceles triangle, this is going to be important because later we're going to learn a theorem about isosceles triangles because there's something else that's true about them. But isosceles triangles, their definition is it has 2 congruent sides. Now you might notice that every equilateral triangle is also isosceles, right? But not every isosceles is equilateral, right? Because every equilateral has 2 congruent sides, but equilateral has 3. So it is a more stringent definition. So we could have 2 kind of like long sides here, and then two short side, and then a short side, something like that, right? Or whatever else. So every equilateral triangle is also isosceles. Now, scalene triangle has, let me see if I can do my best to draw. We should make our colors match. That's important. I don't know why it's important, but it's important. It's totally important. So that looks pretty scalene. So a scalene side triangle has no congruent sides. Not a single one. It has no congruent sides. Not any. None of them are congruent. That's called a scalene triangle. So that's the definitional portion. A lot of these are review. There are a couple that may be new. The scalene may be new. Equiangular may be new to you. But if you add those to your vocabulary, they may all be new. That's entirely possible as well. Let's throw in one example just to kind of round out this lesson and make sure we're doing a good service by you guys and get some more algebra examples in with our geometry problems. So we're going to find the measure of the sides of isosceles triangle ABC. So this is an isosceles triangle. Now, what was an isosceles triangle? What is an isosceles triangle? It is a triangle with two sides congruent. They're actually labeled right here. So we need to make some equations and solve this thing. So if this is congruent to that, then we can set this equal to that, right? So let's do that. Here we go. So 4x plus 1 equals 5x minus 0.5. Let's solve for x. So we need to get our x's together. We need to get our BFFs all joined back up. So we're going to do minus 5x minus 5x. This is geometry. Why not go ahead and also subtract 1 here as well? So this will cancel and that'll cancel, right? Easy peasy, no big dealio, right? We don't like to combine those kind of steps in algebra 1, but we're a step beyond that. So let's upgrade what we're doing, right? So 4x minus 5x is negative x equals, and then negative 0.5 minus 1 minus 1, signs are the same, so we add and keep the signs, so it'll be negative 1.5. We need to get rid of this negative. We're not done until the x, the variable, is by itself. So we're going to divide both sides by negative 1 to get rid of that negative. So x equals 1.5. Now, you'd be tempted to circle that and move on with your life, but we need to go back up and make sure that we're doing all the things that the problem asks for. So it says on the measure of the sides. Well, x is not a measure of the sides. It is a measure of x, right? So what we got to do, of course, is we've got to take and substitute this in there for x. And we're going to plug it in here, and then we're also going to plug it in here. Now, I'm not going to waste my time and plug it in there. Why not? Well, because we know that these two sides are the same. So if I find this side, so the measure of CB is going to be the same as the measure of CA. They're exactly the same because it's an isosceles triangle, right? So I don't have to worry about plugging it into all three, just this one and that one. So let's plug it in right there. So 5 times 1.5 minus 0.5. So let's do that. 5 times 1.5. Give me half. I like to pull up a calculator on stuff like this because I want to remind you guys that it is totally fine to, even if you take and you do this in your head and you think 5 times 1 is 5, 5 times a half is 2.55 plus us 2.5 is 7.5, and you do that in your head and you spit out, okay, this is 7.5. It's okay, even if you do that, it would behoove you to just double check it on the calculator, make sure your mental math matches with your calculator math. And if you're not great at multiplying that kind of stuff in your head, use the calculator. It's a great tool. There's nothing wrong with using a calculator. It's totally fine. Not a problem at all. So see, my mental math was right, 7.5. So, but it's great to go ahead and sanity check that. So 7.5 minus 0.5. I'm just bringing that down. 7.5 minus 0.5. That one's pretty easy. We're going to end up with 7.0 or just 7, right? So we'll label this as the measure of AC equals the measure of CB. You could label that, oops, CB equals 7.0. All right, you could label that as BC as well, or CA, or whatever. Those are the same names. So they're all equal. So there it is. Now we need to find this one, because this one is almost certainly not the same. So let's take and plug it in up there. So let's plug it into 9x minus 1. 9x minus 1. We're plugging in 1.5 in there. 1.5, right? So 9 times 1.5, that would be 9 plus 4.5. So that's 13.5. Let's double check, make sure we're on the right track. So 9 times 1.5 equals 13.5. Look at that. We did it again, but it's a good idea to sanity check. There's nothing wrong. And you can see it took like a second to do. 5 minus 1. So 13.5 minus 1 is 12.5, and that is equal to the measure of AB, segment AB. And that's it for this lesson. We'll get into more things, more theorems, and all of those deals, and we are going to hit some more proofs. I promise you that the proofs in this lesson are pretty dang easy compared to the previous lesson, and compared to some other things later. I think if you're at least kind of sort of starting to get to these proofs, I think you're going to like these proofs. They're going to make you happy, because you're liable to actually get some of them. So we shall see you in the next one. If you're one of my students, do your homework. I'll see you in class. If you're not one of my students, thanks for joining us. Let us know how else we can help you with math or science or any general homeschool knowledge at all. Have a wonderful day. Bye-bye.